If you're interested in learning about SAST tools and SCAR tools, which I think is a dance move? No?
Yeah.
Something like that.
Yeah.
Cool. Then you've come to the right place. So Raafey from Datacom, whose name I just got wrong, please welcome Raafey to the stage with an applause.
Awesome. Thanks everyone for coming. Hello to everyone watching online. Hi, Mum and Dad, if you managed to get the stream up and running. I don't think so, but we'll see. Yeah, it's awesome that everyone's here. Before we kick off, big thank you to all of our sponsors that made this happen. I've been to a couple of online conferences this year. You know, they're not quite the same, so it's really awesome that we can all be here in person doing this sort of stuff. Today, I am going to be talking about what are SAST and SCA, first of all. If you've never heard these acronyms before, I will cover it eventually, so don't worry. I'll talk through how we tested these tools, why we did it, all that sort of stuff. Then we'll get to the title of the presentation, the efficacy of accuracy of SAST, and also the same thing for SCA. And then eventually, right at the end, I will answer the question, is it better than guessing? You may already know the answer. I don't think it's a difficult question, but we did find some interesting things along the way, so hopefully you'll learn something. First of all, who am I? Raafey, so that's the correct pronunciation. That's all good. Not many people get it right, but if you do, brownie points, I'll buy you a coffee at some stage. Right now, I work for the Datacom AppSec team, as you can probably tell by my t-shirt, logos everywhere, that sort of thing. Basically, my job is to preach automated security testing, sometimes to people who want to listen, a lot of the time to people who don't really care or don't want to listen, but I'll keep talking about it because it's great, everyone should be doing it. In the past, I was a Big Four consultant, did a bunch of, cyber consulting, basically trying to convince people they should care about security. You guys are all at a conference, so you probably do, which is great. May have audited you in the past, so if I did, I apologize, but moved on from that. When I'm not at work, I'm a pretty normal guy. I like to travel, like to eat good food. I try not to code on weekends, so that's kind of my mantra. Nice meme. That's the only one you get in this presentation, so enjoy that. Couple of things before we kind of get into the meat of it. My role is to provide guidance on AppSec good practice. I was challenged with kind of looking at all the SAST and SCA vendors, figuring out what works, what doesn't. And what I'm going to present today is sort of the initial view of what we did. So a couple of disclaimers, as always. These are preliminary results. I'm still working through everything. We kind of did it with minimal interaction with the vendors. Because of that, I'm not going to tell you all of the vendor names, but hopefully you'll learn a few things and kind of figure out what to look for, what to avoid, pitfalls and all of that, and make excellent decisions moving forward. So finally, what are SAST and SCA? You may have seen something like this in the past. Any typical application is 30% code that you'll write yourself and 70% code that you've just taken from someone else. Not a bad thing, it's efficient, should do it. These are all the frameworks, libraries, etc. that you pull in to make your application work. Today, we're going to talk about static application security testing, which is for the code that you write. Basically, you have your source code. There is a whole lot of bad patterns, so things that tell you that things might be wrong. We combine that all, kind of put it together, do some magic, and we get what vulnerabilities exist in our code. On the other hand, we have software composition analysis. This is for the code that you don't write. So we have our bill of materials, which is all of the frameworks, libraries, etc. that you are using. Important thing to remember, it's not just the things in your manifest file. They also have dependencies, and then they have dependencies, as demonstrated by this quite ugly looking graph, but really good way just to demonstrate that a lot is going on. We take that, we combine it with a vulnerability database. You may know of NVD by NIST, it's a common one, and then together it spits out what vulnerabilities you have in your source code. So both of them trying to achieve the same thing, doing it in different ways. Yeah. How did we test them? I'm going to talk a lot about OWASP tools in this talk. This is just a fraction of all of the stuff that exists. Guy before me just talked about some great stuff. If you want to know about all of them, my colleague John is doing a talk later in the day. I think he covers off about 50 tools or something crazy. So one, we selected the tooling. We've got 4 commercial vendors. One of them is freemium. We've got FindSec Bugs, which is for Java. We've got .NET Secured Code Scan for .NET. And then similar for SCA, we have 4 commercial tools. One of them is a freemium tool. And then we looked at OWASP Dependency Check and the built-in functionality in NPM, which I quite like and we will go into. We did a bunch of benchmarking to kind of align them all, figure out, just so it can be recreated. We use the OWASP benchmark for our SAST tools, which is actually a Java test suite of about 4,000 things. And it is built purely for testing these sorts of tools, along with dynamic analysis, interactive analysis, etc. It is excellent. Check it out. For SCA, we use nodegoat.js, which is a vulnerable web app, again, OWASP, and it will, it's available online, has a bunch of vulnerabilities in it. You can scan it whenever you like. Then to make things a little bit more real, we took a bunch of our own applications. We ran them through their paces with all of these same tools. In this talk, I'm going to be mainly talking about 2, one in Java, one in .NET. We tested a bunch. This is the ones that we have the most complete results. Still going through it, but we'll talk about those. So before we get into the results of things, I want to talk about the open source options that we have. FindSec Bugs, as I mentioned, for Java tools. Really easy to use, NVM package. It has an IDE plugin, or you can just use it as a CLI tool. Here it is as an NVM package. All you need to do is basically copy and paste this into your pom.xml, copy a couple more files in, and it goes. It'll spit out this nice GUI, which lists out all of the vulnerabilities that exist in your code. It's relatively easy to set up if you've got all the prerequisites, a little bit of an asterisk. Similarly, we have Security Code Scan for .NET and .NET Core. This is installed by either a NuGet package or a Visual Studio plugin. Again, relatively simple to use. If you're going to use the VS plugin, it's literally 10 seconds. It works in the background and on the build, which is quite cool and rare for an open source tool. But yeah, you can test these things out. You can get them up and running. It's not too hard. And there is a whole lot more available at that link. Really interesting that as tools get better, they seem to get bought up by the security vendors. So oh no, it's fallen down. Luckily, I'm quite loud anyways. Is that better? Cool, all right. So yeah, there's a whole lot of tools available online. As I was saying, as soon as they get really good, they get bought out, so the list is slightly out of date. But if you're going to build a tool, someone will probably buy you in a little while, so it's good news. All right, into the actual results now. So we've got this chart, which has been taken from the OWASP benchmark, slightly modified. Across the top, we have the false positive rate. So there's about 2,000 test cases. How many of these were being able to be identified? The OWASP benchmark also has a whole lot of things that look like vulnerabilities, but actually aren't. And that is how we get that false positive rate. Along the middle is, the line that you want to be above, basically. What we're trying to say is if more than 50% of your results are false positives, you may as well kind of have a guess at it. We also have what I like to call the sweet spot right in the top left-hand corner. If you're in here, you're doing pretty good and, well done. So we've got one for the benchmark. We've also got one for our real-world testing. In the real-world testing, these are relative true positive rates because we can't truly know exactly how vulnerabilities exist in your code. But what we did was we took all of the things we found from every vendor, stacked them up, saw how many of them someone was able to hit, and calculated that. All right, so first of all, the benchmark. As you can see, our commercial tools did really well. Number A killed it. It got 80% of true positives and 0 false positives, which is really good. BNC also did pretty good. They're finding a lot of these vulnerabilities. We're starting to creep towards that false positive rate going up, which no one likes. When we take a look at our open source tool, FindSec Bugs did amazing in the benchmark. Important thing to note is that this benchmark is available online, so everyone knows what they're testing against. So they should be doing pretty good. When we start looking at the real world testing, things take sort of a dramatic shift downwards. What's really interesting is the false positive rates actually stayed relatively similar. There isn't a huge difference between the benchmark and real world in terms of how many they were hitting. But again, they shifted down in terms of true positives. But I'm not saying this is a terrible thing because it is relative to one another. They're still doing pretty good. When we take a look at our open source options, one of them's just crept across that line a little bit into the area where we're doing a lot of false positive analysis. And I can let you know from past experience, if you're sitting in a room with a bunch of people, you start talking about false positives, you've done 3 or 4 in a row, people start to get bored and kind of just start drifting away. So it's a bit of a balance between, do we want to find everything that exists in our code and how much time we want to go sifting through the stuff that isn't really an issue. I personally, from a security background, I want to find everything, but I know there's, devs, DevOps people, maybe they're okay with finding a bit less. Our F tool actually did really well on the false positive side, had no false positives, but then again, it didn't find a whole lot, especially in comparison to some of the commercial stuff. So what do you get? Let's take a look at the scan results first. Really good news is that everyone found vulnerabilities. Every single one of the tools that we used found something that we needed to remediate. So if you use one of these, likely that you will find something and you'll be able to fix it, so they're all good to use. Some of them, of course, found more than others, and this is where we start differentiating between the ones that are really good and the ones that take a little bit more of an effort to fix. B and C in particular found a lot more than the others, but this is the point that I was talking about earlier, where there's a bit of a trade-off between false positive rate and true positive rate. So if you want to find everything, you're going to have to sift through a few more things. In practice, though, when we were going through workshops with our devs, sifting through false positives takes a bit less time because there's sometimes really obvious ones that you look at straight away and you go, this isn't anything we need to be a concern of. So, the time graph kind of goes like that instead of rocketing up or going in a straight line. When, of course, I love the results. I really want to focus purely on that, but we have to see how usable and scalable the tool is. First of all, flexible deployment options. Most of the commercial ones will let you set it up however you want, on-prem, cloud, hybrid, whatever you want to do. One of them will only let you do it one way. So if you don't like that method, well, too bad, basically. Pipeline integration, they are all great. Everything works smoothly in your CI/CD. The open source stuff, it doesn't have all the tools and plugins for every single thing available. So if you're using something obscure for your CI/CD, you may have to do a bit more work. Whereas the commercial guys, they have sort of plugins available, makes it a bit easier. Now, this is where things start differentiating, so I've just grouped them all together. Language framework, reporting analytics. If you want this stuff, you basically have to pay for it. And if it's being sponsored by your risk and compliance team, they'll probably want you to have it because they want to see all of the data coming through. Broader security capabilities as well. If you buy one of the commercial tools, they will try to sell you everything. They'll sell you SAST, DAST, SCA, pen testing, training, whatever you need, you can kind of get from them. So if you want everything from the same vendor, you kind of have to start paying for that. Customer support as well. What I want to call out is the open source free tools actually have a great online community. I think I messaged one of the guys who created one of the tools because I was having an issue, who replied to me on Slack within, I think, less than a day. And that's probably because of time difference, so it's pretty good. But of course, you're not paying them. They're not going to fix all your issues immediately. Cost, obvious for commercial, you got to pay. For freemium, there's a red tick. You got to pay for the good stuff. So if you want that broad language coverage, find every vulnerability, you want training, not training, you want reporting, you got to pay. And for the open source, it's free for the tool, but you do have to pay someone to implement it. If you tell someone just to do it in their free time, it's not going to get adopted fully. But it might, depends on how good that person is and how much they care. All right, so moving into our SCA, software composition analysis, we looked at 2 free options. The first one is the OWASP dependency check. This will analyze your project, spit out an HTML report, CSV and JSON for machines to read it also. It's really easy to use. There you go, it's back. If you're using Homebrew, it's literally 3 commands and you can run an analysis. It's the same on Linux and Windows. It's very easy. It spits out an HTML report. Because of the way it does its matching, they call it fuzzy matching, it may contain false positives, and we'll go into this a little bit more in a couple of minutes. And it pulls its data mostly from the National Vulnerability Database, which over the years has been improving quite dramatically. But if you look at some of the really old vulnerabilities, maybe 10 years ago, you'll notice that there's not a whole lot of detail. So when you're trying to convince someone that they need to change their code and update it, and you can't really tell them why, you're going to run into a bit of an issue. Second one we looked at was NPM audit. This is pre-installed in NPM 6+. So if you're on 6+, and you should be, you already have it. It's absolutely free. It's super easy to use. All you need to do is hit NPM audit, and it will spit out this very nice looking report. It's pretty good. It'll tell you how many vulnerabilities there are. And the really cool thing about this is if you go NPM audit fix, it will probably fix about half of your issues right then and there. So if you're going from version 4.4.1 to 4.4.2, where there's no vulnerability, it'll just update it for you. You don't need to worry about it. Of course, if you're on version 1 and you need to upgrade to 7, there's probably going to be some changes and some things that may break your code. So it'll ask you to review it manually and kind of go through the paces a bit. But great option if you are using NPM, just do it. All right, results of real-world testing. Our graph is slightly different on this one. So there's 2 things that we really care about when we look at SCA. Number 1 is how many dependencies it identified. So how sort of correct is the bill of materials that it's making. We've got this line here, which is the actual number of dependencies. SCA tools aren't really trying to get it 100%. They're working on risk, and generally good enough is okay for that. And then across the top, we have the relative true positive rate. Similar to SAST, we stacked all the vulnerabilities it found, how many different packages it identified had vulnerabilities, and we did a bit of calculation to figure it out. This time, we have 3 of these charts. We have NPM, Java, and a .NET Core app. So let's take a look at what happened. For our NPM, all of our commercial tools did pretty well. They're not quite in the sweet spot that I've arbitrarily chosen, but they're pretty close. They're close enough to the line that you're not worried that you're missing 50% of our dependencies, but it wasn't able to pick up everything. Of course, when we throw in our open source tools, what's interesting is OWASP dependency check. I know I mentioned that its matching technique is not as good as the commercial vendors. That's on paper. When we actually did the testing, it was right alongside there, so it's pretty good. L, which is our NPM tool, of course, that's the benchmark we were using to identify how many dependencies were there. So it got 100%, but it wasn't able to pick up as many vulnerabilities because of the quality of the database that it has. It's just taking it from NPM advisory. When we take a look at our Java, it's a little bit all over the place with our commercial and freemium tools. Freemium one did really well, was super close to the actual number of dependencies, picked up the most vulnerabilities by far. When we took a look at the OWASP dependency check, this time it overshot a little bit, so it's picking up things that aren't really in our app, and yeah, the number of stuff that it actually found wasn't quite as good. .NET Core, finally, they're all kind of grouped in there. They're all relatively close. It's really hard to distinguish between them. It's pretty hard to pick a winner purely on results because they're there. H obviously is the best. It's in the sweet spot. It's doing great. And then the dependency check, it wasn't able to find all of the dependencies that were in the app, and it was a little bit lower on the true positive rate. But it is free. So, all right, so the scan results. As I mentioned, similar to SAST, all of these things found issues which we were able to remediate. So that is awesome. If you use one of these tools and your app is a couple years old, you've never run SCA, this time I can guarantee you'll find something. And again, if you don't find anything on an app that is 3 years, let's go 3 years or older, I will buy you a coffee, come find me, show me the results. I'm yet to see it. Now looking at the quality of the bill of materials. So this is our list of everything that was in the app. This time it was pretty hard to actually distinguish between them. We looked at the graphs earlier. Sometimes they were a little bit, up, down. But when you average it out across the 3 languages and all of the apps we used, they're all relatively similar. So I made that point before that, the techniques used by dependency check may not be as good. But in practice, they're probably good enough for what we're trying to achieve and get those security outcomes. And then the final way that distinguish, I think, really happens is the quality of the remediation info. So when you go into these vendor platforms, it really shows you in detail why this package has a vulnerability, what it is, what issues exist, and what you need to do to fix it. When we look at dependency check and NPM, that quality of information isn't quite there. Some of the commercial guys are a bit better than others as well. And now into the usability, scalability, all of that type of stuff, really important if you are a big organization and you want to use these tools. We'll take a look at helps you remediate and exploitability. So these are the 2 things where I think SCA tools are heading. Most of the features in these areas at the moment are newly released, or they're kind of in beta or alpha testing mode, but they will get better over the years. The first one helps you remediate. It kind of does what NPM audit fix does, but sometimes it can do it in a bit of a smarter way. They all do it in slightly different techniques, so I won't go too much into detail. But basically, they will help you either do pull requests or have a nice little wizard that you can go through and go, yes, I will update this one. Yes, I will update this. Actually, no, this one needs to be looked at in much more detail. Therefore, I will go away and do some research and come back, and maybe I'll just suppress it for a month and come back later and have a look at it. Then language frameworks, reporting analytics. As I mentioned, you do basically have to pay for this sort of stuff. Dependency check is really good that it does cover quite a lot. But if you're using some very obscure framework, you probably will need to buy a tool to get the right coverage. In reporting and analytics, shout out to OWASP Dependency Track, which is a tool that I haven't covered in this talk, but it is also excellent. Maybe I'll cover it in the future sometime. It works on a slightly different principle to general SCA tools, but try to achieve the same sort of outcomes, and it does have quite good reporting and analytics capabilities, and it is free. And again, this is the same stuff as the SAST tool, so I'm not going to talk about it too much. You got to pay if you want customer support, if you want everything. There is a really good online community for anything OWASP. They have a Slack channel. They have a Gmail channel? Yeah, something, I don't know what it's called. They have Gmail that you can kind of just post messages to. People reply fast on there. You'll get a lot of feedback, but they're not being paid. They won't do your job for you. And cost. The free ones are free. The freemium one is free up until a certain point, and for open source projects, it lets you do 200 scans or something, and then the paid ones, you got to pay for. Not too complicated. All right, I think I'm almost done. So we can now answer the question, is it better than guessing? No points if you got this correct, but yes. SAST and SCA tools will help you find vulnerabilities in your code. You should use them. It's kind of not really up for argument. Based on all the testing we did, everything finds something that is useful. When we take a closer look at just the SAST tools, a couple of really interesting points that come up. I talked this one a couple of times through. The more vulnerabilities you find, more false positives you're going to find. I'm okay with having lots of false positives because I will just dig through and just find everything left. But, it's something that you've got to balance. And if you're going to get 500 to 10 real ones, people will get bored. They don't want to listen to you. It's something that you need to think about. Open source options exist, but SAST is, commercial will, one, provide you better results and has those kind of features that you need at an enterprise level. I think something that we covered earlier, but I forgot to say, was most of the free tools generally cover one language. So if you're using 5 to 6 languages, you may need to use 4, 5, 6 tools, and manageability kind of goes down after that, and just keeping track of everything is difficult. And finally, if you've been using the same SAST tool for maybe 2, 3, 4, 5 years, I don't know, you may want to consider just taking another look at a different one. Because what we found was all of our tools are actually finding somewhat different issues. So if you've just been rinsing, repeating, you've covered everything in one tool, just give another one a go. You may find something new, and that's awesome. For SCA, if you're using NPM, you've been ignoring the NPM install, which tells you that there's 400 vulnerabilities in your application, please go back to your desk and run NPM audit. It will help you remediate things. Run NPM audit fix. It will help just fix things for you. And the number may go down from 600 to 300 automatically in about 30 seconds. It's awesome. If you're not using NPM, just run a dependency check. It'll take you 30 minutes if you've got the prereqs installed already. It's super easy. Just go ahead and do it. Open source options for SCA, in my opinion, are better at the moment than they are for SAST, largely because of the great work OWASP has been doing. But again, they kind of lack those things that you need at that very big enterprise level. So if you're one of the very big major companies in New Zealand, you probably do need to pay for this sort of stuff. One thing really important that I want to cover that isn't on the slide is just try them out. The free tools, I know I've said this, but they are free. So you can just go home, give it a go, see how it is. And even all of the commercial tools, vendors, I am yet to meet a technology vendor that will not give you a free trial. So if you want to test them out, just go to them, get a trial, use it for a month, see how it goes, how it fits into your environment, and you'll probably make a pretty good decision on the back of that. Final slide, whole lot of resources here. There's a whole lot more as well. OWASP has a ton of things that you should be looking at. And then just a little bit about me. I'm at the Datacom booth. If you have any questions, if you go home and try to run one of these tools and your application breaks, I apologize, but you can come talk to me. I will try to see what I can do. And add me on LinkedIn. I've recently updated my photo to someone who actually looks like me rather than 6 years ago. That is all. So thank you, everyone.
Thank you very much, Raafey. We have no questions from our online callers. Is there anything brief in the room? Okay, we've got a question at the back.
If you come chat to me later, we can talk through that.
What was the question?
It's Nico here. He's asking who one of the vendors
which one of the vendors are. Yeah, thanks, Raafey. I think you put a lot of work into that talk, I could tell, and we really appreciate it. So thank you very much.